Ever wondered if it's possible to travel to a distant galaxy in the blink of an eye? Space travel, the final frontier, has always held a certain allure, a fascination that has captivated mankind for centuries. We've made remarkable strides, venturing beyond our own atmosphere, setting foot on the moon, and sending probes to the farthest reaches of our solar system. Yet, despite these achievements, the reality of interstellar travel remains elusive. The vast distances between stars, measured in light years, present a daunting challenge. Even at the speed of light, a journey to the nearest star system, Proxima Centauri, would take over 4 years. Traveling at the speeds we've achieved so far, it would take tens of thousands of years, a time frame that's simply impractical, making the dream of exploring distant galaxies seem like an impossibility. But what if there was a shortcut, a way to bypass these immense distances? Enter the concept of a wormhole. So, what exactly is a wormhole, you may ask? Well, let's dive into this fascinating concept of the universe. Picture a tunnel, if you will. This isn't your everyday tunnel, though. It's a tunnel with a twist. It has 2 ends, sure, but each of these ends exists at completely separate points in space-time. Imagine a piece of paper, fold it in half, and then punch a hole through both layers. That, my friends, is a simplified representation of a wormhole. Now, this concept isn't as straightforward as it seems. You see, the idea of a wormhole stems from the theory of general relativity. It tells us that space and time are not separate entities, but rather intertwined in a 4-dimensional continuum known as space-time. The intriguing part is that this space-time isn't flat, it's curved, and this curvature is caused by the presence of mass and energy. So, what does this have to do with wormholes? Well, a wormhole is essentially a potential shortcut through this curved space-time. It's like folding a map so 2 distant points touch and then poking a hole through those points. Voila, you've just made a shortcut. But here's the kicker. This isn't just any shortcut. This is a shortcut that could, theoretically, allow us to traverse vast distances in the cosmos in the blink of an eye. We're talking about jumping from one side of the universe to the other, or even traveling backward or forward in time. Of course, this is all theoretical. We've yet to discover a real wormhole, and there are numerous scientific hurdles to overcome before we can even think about using one. But that doesn't make the concept any less fascinating. Just imagine stepping into a wormhole and emerging light years away almost instantly. It's a concept that challenges our understanding of the universe, and one that continues to inspire scientists and dreamers alike. Now that is the wormhole phenomenon. But how could a wormhole work in reality? You might be asking yourself. Let's delve into the fascinating world of theoretical physics to understand the science behind wormholes. To begin with, imagine space-time as a 2-dimensional fabric. This fabric is not flat, but rather is warped by mass and energy, much like a heavy ball placed on a stretched rubber sheet. This is the essence of Einstein's general theory of relativity, which revolutionized our understanding of gravity and space-time. Now, a wormhole, in theory, is a phenomenon that bends this fabric in such a way that it creates a tunnel. Imagine folding our space-time fabric so 2 points are touching, then punching a hole through both layers. This tunnel, or shortcut between 2 distant points in space-time, is what we call a wormhole. But what does this have to do with Einstein's theory? Well, according to his general theory of relativity, the fabric of space-time can be bent by mass and energy. So, theoretically, if we could harness enough energy, we could bend space-time to our will to create a wormhole. The existence of wormholes is supported by solutions to Einstein's field equations, mathematical formulas that describe the fundamental interaction of gravitation as a result of a space-time being curved by matter and energy. These solutions suggest that wormholes are not just science fiction, but could actually exist in the universe. However, it's important to note that while these solutions allow for the possibility of wormholes, they do not necessarily mean that wormholes do exist. Theoretical physics provides us with the framework to understand how they might exist. But empirical evidence, the kind that comes from observation or experiment, is yet to be found. So, in theory, wormholes could exist. But does that mean we can use them for space travel? Well, that's a whole other can of space worms, and we'll delve into that in our next segment. Scene script. Wormhole travel sounds like a dream come true, but what are the hurdles? The first challenge we face with wormhole travel is their instability. Theoretically, wormholes exist for only the briefest moments before collapsing under their own intense gravitational pull, making it virtually impossible for anything to pass through. To keep a wormhole open long enough for even a particle of light to traverse requires a type of matter with negative energy density, often referred to as exotic matter. The existence of such matter is purely speculative, and even if it does exist, harnessing it is another hurdle we've yet to overcome. Next, let's talk about energy. The amount of energy required to keep a wormhole open is immense, far beyond what we can currently produce. Some estimates suggest that to keep a wormhole big enough for a human to pass through open, we would need the energy equivalent to the mass of a star. That's right, an entire star's worth of energy. This poses not just a technological challenge, but an ethical one too. If we could harness such energy, should we use it for wormhole travel, or would it be better spent elsewhere? Finally, even if we manage to overcome the instability and energy challenges, there's the danger of actually traversing through a wormhole. While it's often depicted as a smooth journey in science fiction, the reality could be far different. The intense gravitational forces could stretch and squeeze anything passing through to a point of destruction, a phenomenon sometimes referred to as spaghettification. Not exactly a pleasant journey, I'm sure you'll agree. In conclusion, while the concept of wormhole travel is fascinating and holds immense potential for space exploration, it's also fraught with challenges. Instability, energy requirements, and traversal dangers all stand between us and the dream of stepping through a wormhole to emerge in a distant corner of the universe. It seems wormhole travel isn't as simple as stepping through a door. Despite the challenges, could wormhole travel ever become a reality? As we step into the uncharted territory of the future, there's a glimmer of hope that wormhole travel may not be confined to the pages of science fiction novels. In the world of theoretical physics, the possibility of wormhole travel is being taken very seriously. Researchers across the globe are pushing the boundaries of our understanding, exploring new theories, and making significant advancements that bring us closer to understanding the enigma of wormholes. For instance, the concept of traversable wormholes has recently gained traction. These are hypothetical wormholes that could remain open and unchanging, allowing for the passage of matter. The idea, although still unproven, has sparked the interest of physicists and has led to an influx of research in the field. Furthermore, advancements in quantum mechanics are proving instrumental in our quest to unravel the mysteries of the universe. Quantum entanglement, for example, might give us clues about the nature of wormholes and their potential for travel. However, it's important to remember that these are early days. The theories are still under development, and practical implementation seems like a distant dream. But every step we take towards understanding wormholes is a step towards the future of space exploration. The impact of such a breakthrough cannot be overstated. It would revolutionize our understanding of the universe, leading to advancements in science and technology that we can't even begin to fathom. It could also pave the way for interstellar travel, allowing us to explore distant corners of the universe that are currently beyond our reach. As we voyage into the future, it's exciting to think about the possibilities. Will we be able to harness the power of wormholes to travel across vast expanses of space in the blink of an eye? Will we come across civilizations in distant galaxies? The potential is mind-boggling. While wormhole travel remains in the realm of science fiction for now, who knows what the future holds? Wormholes, a concept that challenges our understanding of space and time. As we've journeyed together through this cosmic phenomenon, we've delved into the theoretical roots of wormholes, explored the intricate science that underpins them, and confronted the daunting challenges that wormhole travel presents. We've also peered into the future, speculating on the potential implications of wormhole travel. Imagine, if you will, a universe where distances that once seemed insurmountable become traversable, where the vast cosmic ocean shrinks into a pond. It's a tantalizing prospect, isn't it? Yet, this is a journey of discovery that's still in its infancy. Wormholes, though theoretically possible, remain unproven and unexplored. They're a testament to the boundless curiosity of the human mind, a symbol of our relentless pursuit of knowledge. As we continue to push the boundaries of our knowledge, we inch closer to potentially unlocking the secrets of the universe. Until then, the mystery of wormholes continues to captivate us.